Hello everyone, welcome to another tutorial. Today we're going to begin the ROS tutorials and we're going to talk about what is ROS and why do we need to learn ROS, and also I'm going to take you through installation process. But to begin with, what is ROS? ROS stands for Robot Operating System, and it is essentially an operating system for communicating with robots, and it's a real-time platform. What does this mean? It offers real-time communication between two blocks of code. For instance, if you have one code that performs image processing algorithm and another code that's in charge of interacting with the robot, and you want to send data from the image processing algorithm to the control algorithm for the robot, this usually has to work under a strict timeline. For instance, you want to send data at, let's say, 50 hertz. How can you do that? ROS gives us the opportunity to enforce this real-timeness, to make sure that the data communication follows a strict timeline. It's an open source platform, and you can develop your code. Lots of people throughout years have developed their code and libraries, and it's free. Previously, we used to teach MATLAB in this course, but outside university, nobody really uses MATLAB, and it's very common to use ROS in automation industry, whether they're dealing with robots or they want to do some automated tasks when they need a real-time platform. So now we have included ROS. It has some features, for instance, offers hardware abstraction. If you want to communicate, for instance, with a piece of hardware, let's say camera or motors of the robot or different sensors, how can you do that? If you usually want to do that, you have to download their APIs, do some coding in C, Python, build your own codes. But with ROS, these all exist. You can easily plug in a piece of hardware, use the code that already has for communicating with that hardware and start working. It offers some other functionalities. For instance, it has a simulator for visualizing robots, simulating their motions. It has package management, basically lots of different packages, blocks of code that exist that you can combine them together. Lots of interesting features that through the tutorials we're going to learn about some of them. History of ROS. It was started in 2007 as a project in Stanford. Back then, people had their own real-time platforms. There are several existing softwares, but essentially ROS became very popular, and in 2013 it became independent, open source platform, and it's available everywhere where there are robots, universities, industries. They use ROS now. Some of its features, what does it do? First, it offers peer-to-peer communication. If you want to communicate between a piece of software and hardware or two software blocks, ROS gives us the ability to do so. It has some API for messaging that we're going to talk about later, ROS messages that enable sending and receiving commands from different blocks of hardware and software, and peer-to-peer, each block directly talk to another block. It is distributed. What does it mean? Imagine you want to build an algorithm for a robot to do a pick and place task. You have a camera, you need to have a block of code to communicate with the camera, record the images. That's one block. Second, you want to write image processing algorithms to detect that object that the robot needs to pick up. Third block, you need codes to interact with the hardware, motors of the robot. Imagine you have bought a robot, now you want to send commands to it. You need a block of code. Another is, imagine you need some algorithms for controlling the motion of the robot to come and grab the object. This algorithm needs to receive the processed image data and then process it itself, send it to the block that interacts with the robot. So now you have lots of blocks of code. How can you use them in ROS? One way is to put all of them in one system, use ROS real-time features to develop a strict communication line between these codes. But it also offers distributed communication. If all your algorithms are very computationally demanding and your computer is slow, your sampling time, or basically the real timeness of the communication line, drops down. It won't be as fast as possible. ROS guarantees real-time communication as long as your computer hardware is capable of it. But if the codes are too demanding, sampling time drops. One thing you can do is distribute different tasks between different systems, between a cluster of computers. Use some parallel processing features. All of these are possible in ROS. Another feature is multilingual. You can coordinate it C++, Python, even MATLAB can be connected to ROS, Java, anything. Mostly, all the libraries are developed in C++ or Python. We use Python. And interestingly, you can use different languages. A block of code in Python interact with C++. Doesn't matter really. It's very thin and lightweight, which means it's not a heavy inert software. It's very thin. That's why it can offer real timeness compared to some other platforms such as MATLAB, which are very heavy, lots of codes running in the background. This is very lightweight. And it's open source, as I said. Several packages are already developed for ROS. All you have to do is find them and use them. If you want to connect the hardware, let's say a camera, for your brand of camera that you pick, there are existing libraries. You can just easily plug in your camera and use them. Now, before getting into more details, I'm going to talk about how to install ROS in your system. We have three options. ROS runs on Ubuntu, and you need to install Ubuntu. One thing is to use a dual boot system, run Ubuntu alongside Windows or Mac. Or just use Ubuntu if you prefer, without any second operator. Another option is to use VirtualBox. If you're using Mac or Windows, you can run VirtualBox app, download it, install it, load an image of Ubuntu, run Ubuntu, then work in the VirtualBox. This would be slower than having dual boot system. Third option, if none of these work, you can use the DICE machines. And now let's try to install Ubuntu together. I'm gonna use VirtualBox because my system is a Microsoft Surface and it's not really compatible with dual boot Linux, so I use VirtualBox. First step is let's download Ubuntu. You can download the Ubuntu desktop image, and you can select any version of Ubuntu, 16, 04, 18 or 20. Depends which one you want. If you already have one, then that's fine, but make sure you pick the proper ROS version for it as well. I'll come to that, but each distribution of ROS works with specific Ubuntu. I'm gonna pick Ubuntu 2004 or Focal and install it on my virtual machine. So if you download this, I already have downloaded, you download an image file. Then you open up your VirtualBox. If you have already installed it, if not, install VirtualBox. I already have one old version of Ubuntu loaded. Just wanted to show you. I will install the 2004 here as well. So I'll create a new operating system, give it a name, and it's a Linux operating system. The version I downloaded is 64-bit. I'll give it some memory from your RAM. I'll give it half of the RAM that's available. And then we need to allocate some space on the hard drive. I'll use a virtual hard disk and make it fixed size, would be fast. How much hard drive? Make sure it's about 10 to 30 gigabyte. Now first we check the settings, make sure it's the correct version. allocated some memory. In terms of display setting, I increases the video memory. If you have more monitors, you can assign a specific monitor to it. For graphics controller, I will use VBox VGA. If you're running Ubuntu and then the window that opens up is small or doesn't match your monitor, change the graphics controller. If you need to add extra USB ports available to use them inside the VirtualBox, include them here. Now we start. It will ask for the disk image for Ubuntu. Then you need to install. So if you were installing dual boot and you're using Ubuntu loaded from BIOS to install it, at this point you have the option to select a dual boot or clean the previous operating system. After finished installation, we need to restart. Okay, one thing I'm gonna do at the beginning is change the font size so you can clearly see the commands I'm using. Now that we have Ubuntu, we will install. First thing, let's install OpenCV before ROS because we will be using it a lot for computer vision. First, we will open a terminal. You can access the terminal here or simply by using Alt, Control and T. First thing, I want to install OpenCV, but before that I need to update the newly installed Ubuntu. I install OpenCV using sudo apt command. So it needs to be Python 3. To make sure that you have OpenCV installed, we run the command to print out the version of OpenCV in our system. So I will open up a Python environment, import OpenCV module and print the version. 0.2. So we have OpenCV installed. The next step is installing ROS. So first we use the ROS website to see which distribution we need to pick. All we need to do is go to ros.org. There are different distributions available. Each distribution is for a specific Ubuntu. For the version of Ubuntu that we installed, Ubuntu 20.04, the ROS Noetic version is the proper version. If you go to wiki page here, you will see all different distributions available under install. The three most common distributions are Noetic, the most recent, Melodic, and Kinetic. Any of these would be fine. They're not that much different. And Kinetic version works with Ubuntu 16, Melodic Ubuntu 18.04, and the recent version is Ubuntu 20.04. So depending on what version of Ubuntu you've installed or have on your computer, select the proper installation. I use the Noetic that matches Ubuntu Focal. Note that ROS is also available for Windows, but this is an experimental version of it and it's not stable. So we're gonna stick with the tested versions for Ubuntu Focal. If you go to the wiki page under installation, there is all the guidelines that you need to install it, and basically a bunch of commands that you need to copy paste. First, we need to copy this line to make sure that our computer can accept command from the ROS website. Setting up the keys. Installation, we need to update the system first. And you have the option to do a full install or install specific packages. We're going to do a full installation. This would take a while. Now that the installation is complete, we need to set up our environment in Ubuntu. So every time that you run Ubuntu, it makes sure that when you open up a terminal, ROS is already ready to run. You can do that using the source command and source the bash file for the ROS. You have to repeat this every time you open up a terminal. There is another option to permanently write this in your Ubuntu bash file, so whenever you open up a terminal, automatically runs this line. You can do it really by copy and pasting this command. Echo source this command into bash. So this will copy this line into the bash file for Ubuntu. So every time you open up a terminal, this command will be automatically run. Then you're ready to run ROS. Just to make sure that you have installed ROS properly, let's run ROS core command. ROS core enables ROS. It starts running. If it's working, then you have ROS installed. I can cancel it with Control and C. You can also check the gazebo environment, which is a simulator in ROS. You're gonna work with this in the lab, and it is an environment that's used to simulate robots. So if your ROS is installed properly, you should be able to run the gazebo simulator environment. So this concludes our tutorial. We talked about ROS and how to install it. See you in the next tutorial.